Hello, this is Memphis University. Today we are practicing some AP Calculus free response questions. We are doing difficulty 8 of our AB multiple choice like free response questions. So these are the free response questions that are not categorizable under things like particle motion or graphs or something like that. So they're basically a bunch of multiple choice questions just combined into one single free response question. And oftentimes on the AP exam, you can really prepare for 5 of the 6 free responses, expecting a rate in, rate out question, maybe an area and volume question, a particle motion question, things like that. But there's always that sixth free response question that you really can't prepare for in terms of seeing old free response questions. And that last free response question could range from very easy to very hard. So what we've done is we've created 10 free response questions that have been the miscellaneous frick in the past on the AP exam, and we've just gone difficulty 1 all the way through difficulty 10, this being difficulty number 8, this video. And we slowly try harder and harder fricks, and hopefully we will improve. So this free response is number 8. Again, I recommend watching this entire series out of any of the series that we have, because this will allow you to get a lot of exposure to these miscellaneous type of free response questions. Also, all the topics that we cover in this series on these AB multiple choice like questions often come on the multiple choice. That's why they're multiple choice like. So if you watch all these videos, you might be hitting probably 20-25 topics on the AP exam in the multiple choice section, and there's only 45 questions, so that's quite a bit of the curriculum of AP Calculus AB. So today we have difficulty number 8. This free response question was, of course, written by myself, but it is based off a former free response question that I found. Supposedly, this question that it's based on, the real AP exam, is the lowest scoring AP exam score ever. Basically, I think it was supposedly like a 1.5 out of 9 nationwide. And you can see why when we do this, when we start this question. But what I would preface is that this question isn't actually too bad, actually, in terms of difficulty. We actually ramped it up a little bit because it's difficulty number 8 out of 10. I believe that so many people did badly on this free response question was because they just didn't know what to do. But if they had known what to do, the actual methods and the actual processes of the questions wasn't too bad. So you're going to see, we're going to be using this table. You're going to see some questions that people have trouble with. So these two are IVT, MVT, as we'll point out. This is taking a derivative of an integral, probably the easiest part of this free response question. And then we have something about inverse functions, which is a formula that a lot of students don't know. So as we start out, if you want practice on these questions, I can direct you to videos in our own channel on these topics. MVT, IVT, we have a video on. Inverse functions, we have videos on. Derivatives of inverse functions, that is. And then fundamental theorem of calculus part 2, which we refer to as taking derivatives of integrals. That we have a video on that as well. We also have videos on other topics before we get started, something called table fricks. So you might think, why is this not a table frick? Well, table fricks I usually consider as situational fricks, like, for example, temperature or particle motion inside a table, where in that frick, somewhere you're doing a Riemann sum, but we're never doing a Riemann sum here. We're not actually doing a lot of integral calculus in this free response question. So I'm going to count this as a miscellaneous one, but feel free to check out those table free response questions. We go from difficulty 1 through 10 as well on our channel, and those are always on the AP exam. It seems like it's every single year in the non-calculator. Maybe the first non-calculator question is a table free response question, but in that case, that's a little bit different. So we'll leave that to another video or another video playlist. So let's get along with this question. It's not going to be too bad. Again, as I go through it slowly, once I explain how to do each question, I feel like it's not too bad. There's no hard integrals, or there's no drawing graphs or anything like that, or doing like trigonometry stuff. So I think it won't be too bad. So let's get started. So we have this giant table. It has F prime, G, and G prime. This is F prime. Sort of messed up my prime here, but it is F prime. And it looks like it's at 1, 2, and 3. None of this paragraph is too relevant. It just explains the table. What is important is this new function h, which is 2 times g of f of x. Hopefully you can tell that's f of x minus 3x. So let's get started with the first question. Let's actually look at the first 2 questions back to back. So the first 2 questions are related. Notice that they are very similar. One says that we want to show a constant exists where h of that constant equals -8. So h basically the function h achieves the y value -8 at some constant a. And then here we have the same thing, but it's h prime. So if you've watched our video series on table free response questions, this is the MVT IVT question as alluded to before. So remember that IVT and MVT are actually existence theorem proofs. They don't actually give you numbers. They just say certain solutions exist. So I'm never going to find A in this case. I'm never going to find B in the second part. Like my answer is not going to be A is equal to -2 at the end, sort of like with every other piece of calculus where you take derivatives and the final answer is a number, or you take an integral and the final answer is a number. IVT and MVT just show the existence of. So you can really spot these questions out, especially when you have a table. But it's sort of a weirdly worded question. The question isn't as find the A such that this occurs. Sorry about that. The question is show that there exists, or why must there exist? Or what's the least number of times that this has possible? Those are your sort of worded questions for IVT and MVT. So let's try IVT or MVT right now. So again, right when I see this question, even from the word show, there's not much showing on the AP exam versus determining or evaluating or finding. So the verb show really tells me this is probably going to be IVT or MVT for both of these questions. And if you have two questions presented in this way, one of them is probably IVT and one of them is probably MVT. So the next thing to do is to determine which one should I use. Should I use IVT or should I use MVT? Well, IVT, remember, is for showing for functions themselves. It's not actually a calculus theorem. It's a algebra 2 or a pre-calc theorem that is used in calculus. So it's oftentimes, if it doesn't have a derivative, like in this case, it's just plain h, that's a good indication that it's IVT and not MVT, because it's h of a and we have h of x in the function. We'll look in the next question. It looks like it's h prime. H prime is probably going to be MVT, because MVT, the phrase is there is some b in the interval where the calculus slope of b is equal to the algebra slope over the entire integral. The entire interval, not integral. So when you see a derivative and it's a derivative of the function, it's probably going to be MVT. So this one, again, is probably IVT or MVT just from the verb show, but this one is probably MVT. So that's sort of my thinking as I do these questions. But let's take this first question, and then let's take the second question. So this first question, again, is IVT, because here the function matches the given. And IVT, what you want to do is you want to show that -8 is in between the y values of the endpoints. So what we want to do is we want to find h of 1 and h of 3. We're just going to find those numbers using this function and the table. And then we're just going to show that -8 is in between those numbers. So let's do that. So again, we're not even ready for the question yet. We just need to find h of 1 first and h of 3. So I'm going to do that on the bottom here. So h of 1 and h of 3. So h of 1, it looks like we plug it into this guy. So it looks like we get 2 g of f of 1 minus 3 times 1. Well, f of 1 from the table is 3. So it looks like we get 2 times g of 3 minus 3. And again, we don't have to think about g of 3. G of 3 is from the table. It's right here. It's -2. So it looks like we're going to get -4 minus 3, which is equal to -7. We'll write our IVT sentence in this box. Hopefully we'll be able to fit it in. Maybe we'll need some space. Now we're going to do the same thing with h of 3. So h of 3, again, we're just going to plug it into this formula. So IVT is called the intermediate value theorem because it's the intermediate value theorem of y values. So you always want to find the y values first. And if this were on f and g, I wouldn't need to find the y values because here are the y values of f and here are the y values of g. In this case, we are doing IVT and MVT on a newer function. So that's why this FRQ is a little bit harder than normal. This is on h and not f or g. But let's finish this out. We are going to plug in 3, so we get 3 times 3. So it looks like this will be -9. And then let's look in the table. What is f of 3? Well, f of 3 is 2, it looks like. So it's going to be 2 times g of 2. And g of 2 is 0, which is nice. So that's 0 minus 9, which is equal to -9. So now we're ready to do IVT. So we write by IVT. Anytime you use IVT or MVT, it's nice to start off with by IVT or by MVT. And then I'm going to put my justification, which in IVT, all you have to say is -8 is in between these two y values. So because -8 is in between h of 1, which is equal to -7, and h of 3, which is equal to -9. So by IVT, because -8 is in between these two y values, that's actually my justification. I just showed that -8 is in between these numbers. It's in between -7 and 9. It could have been switched around, and -8 obviously would still be in between -9 and -7. Doesn't have to be midway. It could have been any number. So none of the work would have changed if this number were, for example, -7.5. So this is we write by IVT, we write the justification, and then we just have to conclude. And how I like to conclude is I just like to copy their sentence and change it to a statement. So it said show that there exists, but I'm going to have by IVT, my justification, and then I'm going to say there does exist. Whatever they want, an A, blah, 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 all the way up to the period. Such that, we'll write ST for such that because we're losing space. And we got h of 8, -8. And that's how IVT works. Again, what you want to do is you want to show the given y values in between the y value of the function you care about. In this case, we care about h. So we found h of 1 and h of 3, and -8 is in between -7 and -9, which are the h values. So that's how you do IVT. Let's go on to this MBT question. Again, right when you see the word show that there exists or why must there be, that sort of wording, you know it's IVT or MBT. Because the given is h and the question is h prime, my first instinct is that this is going to be MBT instead, because MBT involves a derivative. Mean value theorem, meaning the mean as in the average of the algebra slope on the interval. So how I do MBT is I like to write by MBT, and I start doing my justification. So in MBT, it's a little bit different than IVT. IVT, this number really doesn't matter as long as it's in between these values. When we do MBT, which I remember as the phrase calculus slope equals algebra slope, basically you're setting the two kinds of slopes to be each other. You need that algebra slope to be exactly -1. So there's no in-between action here. We want it to be exactly -1. If we're not doing it, if we do it right, we should get -1. So let's try that. So because we're going to do algebra slope, which is going to be y2, y1. So these are the two x values over 3 minus 1. So if this were a done question, I would have to find h of 1 and h of 3 all over again. But we did that in the previous question, so I'm just going to use that. So it's going to be -9 minus -7 over 3 minus 1, which is 2. If you do -9 minus -7, that's the same thing, of course, as -9 plus 7. -9 plus 7 is -2. -2 over 2 is -1. So this is the MBT justification. I showed the calc slope equals, sorry, not the calc slope, the algebra slope is equal to what they want the calc slope to be. And that's what MBT says. So again, this is the justification. This is by IVT, MBT. So all we're going to do is similar in this case. We're just going to rewrite their sentence as my concluding statement. So there does exist a B for which B is in this interval such that h prime of B is equal to -1. So again, not too bad of questions in my opinion, even if they are hard, because it's not your typical IVT MBT question because it's on h, but the given functions are f and g. But h relates f and g, so that's how we were able to do it. Let me just do a quick reminder. If you ever see the word show that there exists, or why must there be, or what's the fewest number of times that this must happen, that's usually IVT or MBT. IVT is if the function matches the one they give you, so h and h. MBT is when it's the derivative of the function that they give you, so it's h prime here, because MBT says calculus slope equals algebra slope. That works most of the cases, probably like 85 to 90% of the cases. And then for IVT, what you want to do is you want to show that the want y value here, -8, is in between the y values on the endpoint. So you need to find the y values of the endpoint and just conclude that -8 is in between -7 and -9. Furthermore, for MBT, what you want to do is you want to find the algebra slope on this interval and make sure it's exactly the slope that they want, which in this case is -1. And then you conclude the sentences by just basically copying their statement in statement form, or their question in statement form. So again, not too bad. MVT, IVT, pretty typical versions of MVT, IVT. So now we're on the back. Not too bad as well. I redrew the table so that we don't have to keep flipping back and forth. So this question is probably the easiest question of this free response, in my opinion. So let's review a little bit fundamental theorem of calculus part 2. So let's say we're taking a derivative of an integral. Let's say, for example, 2x squared of sine of t dt. Obviously, when you're doing your own free response questions on a test, you don't have to create your own questions. But here, I'm just trying to illustrate a purpose. So here I'm taking a derivative of an integral, derivative of this integral. So what you do, remember, is that basically, not exactly, but basically, derivatives and integrals are inverse processes. So when you do one and then you immediately do the other, you're just going to get back the original. So all you do to take these derivatives is you write the original, sine, you plug in the inside function, x squared. But this inside function is an inside function. That's basically what it is. It's an inner function. So when we're taking the derivative of this function has an inside function, so it requires the chain rule, the inside function being the top. So all you have to do is multiply by the derivative of the inside, so you get 2x. So this is what I call the fundamental theorem of calculus part 2. Some other teachers switch it around in terms of which one is part 2 and which one is part 1. But again, it's one of the easiest questions on the AP exam, especially because they think it's pretty hard. So it's in the range between 20 and 30 on the multiple choice, as opposed to 1 through 10 on the non-calculator section. And it's one of the easiest questions because, again, it's a derivative question, actually, and not an integral question. And all derivative questions are usually easier than integral questions. So again, all you do is you just plug in the top thing, the top upper limit, the x's, into your variable. And then you multiply by the derivative of the thing you plugged in and not the thing you plugged in to. So for example, notice I don't have any times cosine at the end. That's wrong. You have to multiply by the derivative of the real inside function, which is in this case the top one. So all that is to say, the next question is not too bad. So let's do it. So we're going to have s prime of x. Let's find s prime of x before we find s prime of 3. So we have to take this derivative. Well, look, the 2x is outside the integral, so let's just take this derivative right now. That's just plus 2 at the end. Not too bad. And then we're going to do the same thing. We're going to take a derivative of this integral. So what we're going to do is we're going to plug in the function into my t. Sorry, this should be t. We're going to plug in the function into my t, so we're going to get g of f of x. But we, of course, need to remember to multiply by the derivative of the inside function, because that's the chain rule. So we do need to multiply by f prime of x. So this step right here was the chain rule, the most important rule when you're taking derivatives. And that's FDC2, which we have videos for if you want to watch and practice more examples. The example is being more like this. So again, all you do to take this derivative, you just plug in. So you get g of f of x, and then you multiply it by the derivative of this thing, which is f prime of x. So now that we've taken the derivative, the rest of the question should be pretty easy. All we're going to do is we're going to plug in 3. So we're going to plug in 3. S prime of 3 equals g of f of 3. I think I have enough parentheses, times f prime of 3. Remember this plus 2 because the derivative of 2x was plus 2. So now the table comes in handy. What is f of 3? Well, f of 3, this is not the best question I've ever written, but it's fine. F of 3 is going to be 2. So we're going to get g. Sorry, I did the chain rule. It's g prime of, sorry. I didn't do the, no, it's not g prime. It's just g, because you just plug it in. Sorry about this. Got confused a little bit. It's just g. So again, all we did was from x's, we just plugged in 3's. Got a little bit confused for some reason. So f of 3 is 2, so we get g of 2. Times f prime of 3. I'm going to replace f prime and 3 with what it is. It is 7. And then g of 2 happens to be 0. So that's why I said it's not the best question in the world, because we ended up getting, none of this actually mattered. It was just 2. But hopefully you see how to do it. I did get confused a little bit with that prime, because I thought for a second I did the chain rule wrong. But we didn't take a derivative from this step to this step. All we did was plugged in. And why is there not a g prime here? Well, all we do is we take the derivative, plug in f of x into this thing. So again, let me remind you what we did. To take a derivative of an integral, all you do is you plug in the top function into the integrand, the thing in the integral, and then what you need to remember is to multiply by the derivative of the top thing. Sometimes it's an x, so it's just times 1. Sometimes it's an x squared times 2x. In this case, it's f of x, so we multiply by f prime of x. Finally, we had this plus 2x randomly, so we did take the derivative of that as well. And then hopefully you won't confuse yourself like I did. All we're going to do is plug in 3 and then use the table. So f of 3 is right here. F prime of 3 is right here. And then we need a g of 2, which happened to be 0. So that's what made the question a little bit weird at the end. But try to not confuse yourself. But in these FRQs, we're at a such high level, difficulty number 8. So don't feel bad if you confuse yourself. Just think slowly and you will probably get out of that hole that you are trying to get out of. Definitely mistakes are made. If you watch a lot of our videos, you can tell you have known that I make basically a mistake in every video. But mistakes are part of the process. That's how we get better. So do not feel bad when you make them. Every single person makes mistakes. If you're not making mistakes, you're probably doing too easy of math. And you should probably try to do more challenging things. And then you will make mistakes. So this last question is the inverse function question. So this is the formula that involves the derivative of an inverse. It's one of the most missed questions on the multiple choice, not because it's hard, but because people just don't know this formula. It does come from the chain rule and the definition of inverses. But basically, the derivative of f inverse prime, so f inverse prime is equal to 1 over f prime f inverse of x. So this is the formula for inverses. So we can write that. This question's a little bit weird because the question actually isn't about f inverse. It's actually about g. But what I want to do first is I want to list out a point. F inverse as something, whatever the point is, and then I'm going to list out the derivative as well. So that I can find the equation of the tangent line. Even if it's of r, this will help out. So I'm going to ignore r for now and just do a normal inverse question. I've actually never seen an inverse in another function before, but I thought we could be a little bit spicy because this is difficulty number 8. So first off, I do need a point. This is the key. So what I like to do is I like to write out the points of f. So I'm going to write out the points of f. So it looks like it's 1, 3. 2, 1, 3, 2. And then the points on f inverse, how it is it's the inverse. So what you do is you swap the points. If x, y is on f, that means that y, x is on f inverse. So 3, 1, 1, 2, and 2, 3. An example of this is squaring and square rooting when their inverses on their respective domains. So for example, 3, 9 is on f on this square function, so then 9, 3 is on the square root function. So again, if 1, 3 is on f, that means 3, 1 is on f inverse, and so on. So in this case, we want to find where f inverse has the x coordinate 1, so that's going to be 1, 2. So be careful, it is not 1, 3, that's f, this is 1, 2. So our point is going to be 1, 2. And then we're going to apply this formula to the point x is equal to 1. So we get f inverse of 1 equals 1 over f prime f inverse of 1. Well, again, what is f inverse of 1? It is 1, 2, because this is f inverse. If you wanted to read from this little table to accompany the given table, f inverse of 1 is 2. So don't panic when you can't see f inverse. You use the switching action. X, y becomes y, x. So in this case, we get 1 over f prime of 2. Now, all we have to do is go to the table. 2 is this, so the answer is -4. Just be careful, though. There is still this 1 over. So some students get too eager, and they find this -4, and they just box that. But you do have to do 1 over -4. Now we're ready for actually r, because the question is about r. So let's plug in r of 1 first. So we get 2 times f inverse of 1 plus 1 squared. Not super exciting because we have 1 squared, but that's fine. F inverse of 1 again is 2. So this is going to be 2 times 2 plus 1. So it's 4 plus 1, which is equal to 5. Now we are going to do r prime of 1. That's going to be, well, we don't need to do the product rule here because it's a constant times a function. All we need to do is write 2 times f inverse prime. We're going to plug in 1. And then the derivative of x squared is, of course, 2x. So that's 2 times 1. Now, we need to know f inverse of 1, but we just found that. That's negative 1/4. So that's why we did it beforehand, to make everything a little bit simpler. Now we just have to do a little bit of fraction work, which isn't trivial. 2 times negative 1/4 is negative 1/2, plus 2 is equal to 3/2. So we have the point and the slope. We are ready to write the equation of the line. If you have watched our videos, you know that I'm quite messy, so I'm just going to randomly put it in this box that I'm drawing right now. So I'm always do point slope form because point slope form is the best form. I'm going to write y minus 5 equals the slope 3/2 x minus 1, and we are done with the question. So again, this is a notoriously hard free response question, supposedly the hardest question ever written, or if not the hardest question, at least the one where students have performed the worst on. But that's not because of the students' abilities, that's just because the students sort of had small gaps in their knowledge in terms of MVT, IVT, and inverse functions. So remember that if the wording is weird, it's in IVT or MVT. IVT is they match the function value equals a number. MVT is the calculus slope, the derivative. IVT, what you want to do is you want to show y values in between. So that's great. MVT, you want to show that the algebra slope on this interval is exactly this number. To take the derivative of integrals, what you do is you plug in, all you do is you take, get rid of the integral basically and just plug in f of x into the, whatever your upper limit is, into your function. But remember to multiply by the chain rule of the derivative of the top of the function, the thing you plugged in, and not, for example, the thing you plugged in to. So there's no g prime here. Don't confuse yourself on the easy steps when you just plug in 3. Read the table. Sometimes you get weird numbers like 0. Finally, inverse function is not bad as well. It's just this formula. It's usually presented with g, so a lot of times it's g prime of x equals 1 over f prime g of x, where g is the inverse of f. But it's not too bad. List out the points of f first, swap those bad boys, and then when you want to find 1, once you swap the points, you know that 1, 2 is on f inverse. Then you apply the formula. So we need to find f inverse of 1, but again, that's 2. And then you find f prime of 2 either from a table or from a function that you can take the derivative of, and then you have the slope. And then in this case, we had a little bit of a fun little ending where we actually were working with r that involved f inverse. So again, I'm hoping that this video series is useful for you. I recommend watching again from number 1 to number 10 so that you can sort of shore up those small gaps and you will be confident as you experience these seemingly difficult free response questions, but are actually not too bad. So thank you for support and in terms of your watching this video. We really appreciate it. I will see you soon, and we will have 2 more videos after this in this playlist, difficulty number 9 and 10. So check those out if you want a challenge. Challenges are, of course, very good for us. And until then, thanks for watching. I'll see you later.